Hello there, I'm Hamza Luwama, here to take you through some mathematics, and today I want us to share with us a concept called integration. And in integration, we have various techniques of solving problems and solving numbers in mathematics, and this is normally mathematics at advanced level and university math and the like and beyond. So today, we would like to look at type 1 of integration, and the type 1 I want to talk about is what we can call integration by trial or by inspection. And according to this statement, it means you have to first inspect or try the integral and find out how did that integral come about? Where did it come from? You ask yourself that question. But how do I get to know that this is the type of technique that I want? It depends on the problem given. If you look at an integral, for example, integral of, for example, if they give you integral of x into x squared plus 1 to the power 3 with respect to x, then you ask yourself, the term inside the bracket has the highest degree of x as x squared. The term outside bracket has the highest degree of x as x power 1. So it means the x power 1 perhaps could have come from the derivative of x squared. So that's what you inspect. That's why I'm calling it integration by inspection or by trial. In that regard, I'll have to inspect the derivative with respect to x of x squared plus 1. But this time round, the derivative I'll inspect will be raised to a higher power. So that means the term inside the bracket, you increase its power by 1 and then inspect it and differentiate it and find out, does it realize what the question says in the integral? So let's check it out. You'll have to see that this is 4, if you differentiate using the power rule, brackets of x squared plus 1 to the power 3. Then you differentiate the term inside the bracket and you'll have to get 2x. So this will give us actually 8x into x to the square plus 1 to the power 3. This is the same as what the question has. So by trial, I have seen where this question is originating from. So I can make it the subject and I'll have the derivative with respect to x of x squared plus 1 to the 4th divided by 8 is actually going to be equal to x of x to the square plus 1 to the cube if I cross multiply that dx. So the moment this dx has cross multiplied on this other hand, I can introduce the integral symbols. When I introduce the integral symbols, integral of a derivative, you get that very term. So I'll get 1 over 8 of x to the square plus 1 to the power 4 plus a constant is equal to what the question was suggesting. So in this case, I have integrated this question or this problem by trial or by inspecting it, by asking myself, where does this integral actually come from? That was example 1. Because this kind of integration and presentations we are having the 5 integrals. So today we are going to have the 5 integrals of type 1. So type 1, we have example 1. We can now get example 2 of type 1. Example 2, I can have the integral of the kind. Integral of sec to the square of x tan of x dx. This is a trig function. It's in form of a trig function. It's not in form of a polynomial. So in this case, we have to think outside the box a little. You'll find that in this case, you cannot easily inspect and say that, for example, the derivative of tan gives you sec squared. But how about the tan that is remaining here? That cannot help us much. How about what if someone inspects and is like, what if I investigate sec x? When I investigate sec x, I'll have sec x, the derivative of sec x is actually sec what? Sec x tan of x. So it means someone can be in position to say the following. I can introduce by thinking outside the box. This is sec x tan of x dx. So that this is the derivative of that one. If yes, I increase the power of the original function. So this time around, I'll have to investigate sec squared x. If I inspect sec squared x, what will I realize? I'll realize twice power rule, because we normally say PTA, power, trig function, then the angle. So if I differentiate the power, I get 2. I get sec of x. Then I differentiate the trig function. The derivative of sec we have already seen is sec tan. So I'll realize sec tan of x. Therefore, this is in line with what the question had stated. So this is actually what the question is, and for that reason, I'll have sec squared of x of dx is actually equal to twice sec squared of x tan of x. If I cross multiply, I'll have the derivative of sec squared x divided by 2 as equivalent to sec squared of x tan of x dx. And this clearly has introduced the question. So I introduced my integral symbols. For that reason, the question is that, therefore, the integral of sec to the square of tan of x dx is actually going to be a half sec to the square of x plus a constant. So with this, we have looked at the second example of type 1 of our integration today, and which type 1 we had called the inspection method or the integration by trial technique of integrating functions. So let's take a look at example 3 of integration by trial. For example 3, I can integrate x squared square root of x to the cube plus 1 with respect to x. This is the same as writing it as x squared into brackets x to the cube plus 1 to the power r half with respect to dx. So in this case, still, I've always said, emphasize the bracket. The bracket is where we have the bigger function. And ask yourself this question: is the term outside coming from the derivative of the inside term? If yes, then I can call for this method of integration by trial. So I can inspect this by doing what I've done before, increase the power on the bracket. So x cubed plus 1, if it had power half, it goes to power 3 over 2 if I increase the power. And this will definitely take me to, when you differentiate this, you'll have 3 over 2 of x to the cube plus 1 to the power r half. When I simplify to design the question, before I can go to the design of the question, after differentiating the power, you have to also differentiate the inside term. The inside term is 3x squared. So when I differentiate x cubed, my result is 3x squared. So therefore, when I multiply these two, I'll realize 9 x to the square over 2 into x cubed plus 1 to the power r half. When I make them the subject, I will have x to the cube plus 1, the power 3 over 2 times 2 over 9 is going to be realizing x squared of x to the cube plus 1 to the power r half with respect to x. This is exactly what the question is stating. For that reason, you will introduce the integrals on both sides. Therefore, the integral of x squared into x cubed plus 1 to the power r half with respect to x is going to be twice out of 9. Integral of d of x, you get that very term. So this is going to be x cubed plus 1 to the power thrice over 2 plus a constant. We are integrating by inspection, or we are integrating by trial. And the best way to have all these techniques well mastered is by people going to different textbooks and try out as many numbers as possible. We have very interesting books around the world. Internationally, we have Backhouse 1, Pure Mathematics by Backhouse 1. We have Pure Mathematics by C.J. Tranter. We have Pure Mathematics by Parkins and Parkins. We have Pure Mathematics by Bostock and Sadler, which is Understanding Pure Mathematics. So there are various books we can reach out to and get more examples on this. We can even visit online and check on the books online. Go to Google Chrome. In the search engine, you can type in examples on integrals of this kind of technique. So that was example 3 of type 1, which is inspection by trial. Now I want to give you another example, which is example 4, which is integral of sine to the square of 4x cos of 4x dx. The definition technique is still the same. Ask yourself, inspect it. Is the cos 4x coming from the derivative of sine squared 4x? Sine of 4x? Yes. But does not exactly give the derivative of sine squared of 4x. So inspect the derivative of sine squared 4x by increasing the power of the highest degree of the two terms. So I will inspect the derivative of sine to the cube of 4 of x, and this will give me, using PTA, which is power, trig function, and the angle. I'll differentiate the power and realize 3 sine squared of 4x. Differentiate the trig function. When I differentiate the trig function, I get cos of the same angle. Then lastly, differentiate the angle. When I differentiate the angle, I'll get a 4. This will confirm a 12 sine to the square of 4x cos of 4x, which is exactly similar to what the question suggests. For that reason, I can now make them be separated in terms of this. As you can see, I've brought the 12 on this hand. I'm taking the dx on the other side to match the question so that we can have sine squared of 4x cos of 4x with respect to x integral. When I integrate, I'll have the integral of sine to the square of 4x cos of 4x with respect to x is equal to a 12th of sine to the cube of 4x plus a constant. And with this, we have managed to handle question 4, which is under type 1 of integration. Lastly, I have type example 5, which says integral of x plus 2 to the power 10 dx. Why some of these methods have been introduced is because you cannot easily expand as far as power 10. So you ask yourself, can I use inspection on this number? Is the term inside the derivative of the outside? Is it giving us the derivative of the outside term? The outside term, actually, there is a silent one. Sometimes we can call it a useful one. That one could be coming from the derivative of x. So inspect that. But before you inspect it, remember to always increase the power of the bracket. So therefore, if I'm to increase the power of the bracket, I'll inspect the derivative of x plus 1 to the power 11. I mean x plus 2 to the power 11. Then when I differentiate this, I'll get 11 of x plus 2 to the power 10 times 1. That's how it realizes 11 of x plus 2 to the power 10. To design the question, remove the coefficient 11 by bringing it on this hand. You'll have d out of 11 of x plus 2 to the power 11 is equal to x plus 2 the brackets to the power 10 with respect to x integral. With this, you can definitely have x plus 2 to the power 10 with respect to x. The answer is 1 out of 11 of x plus 2 to the power 11 plus a constant. The constant c is always the constant of integration, and this occurs to what we call indefinite integrals. With time, we shall also see what we call definite integrals. For them, they will be having limits with which we can as well always find a way of how to handle them, and then we can eliminate the constants. But for today, we have discussed what we call integration by trial, which is type 1 of integration, or integration by inspection, and we have seen how we have inspected some of these integrals to realize their solutions. My name is still Hamza Ruwama, and I've been here taking you through integration of type 1. With that, we can have an illustration of a definite integral, whereby the integral can come through when it has limits. For example, from 0 to 1, integrate x out of x squared plus 1 to the power 3 with respect to x. Now, sometimes learners may not easily see this, that this is an inspection technique. But rather, if someone writes it with all the functions lying on the same line, then they can clearly see that actually x is a derivative of this term inside the bracket. And we are integrating it from 0 to 1. So still, we carry out the same technique, inspection. What do I inspect? I inspect the bracket. When I inspect the bracket, I'll have x squared plus 1, but increase the power of the bracket. This time around, the bracket has a power of a negative 3. Negative 3, when you increase its power, it becomes negative 2. So when I differentiate this, I'll get a negative 2, brackets x squared plus 1 to the power negative 3 times the derivative of the inside term, which is 2x. Then it is from here that you realize that this is a negative 4 of x into x squared plus 1 to the power negative 3. When I split them, I'll have the derivative with negative 4 down, x squared plus 1 up, power negative 2 is equal to the integral of x squared plus 1 power negative 3. This is going to realize the integral of x squared plus 1 power negative 3 with respect to x, because here there is respect to x as we made the x go the other side, is going to be equal to a negative a quarter of x squared plus 1 to the power negative 2. But remember this time round, when I say plus a constant, we had in limits from 0 to 1. So this is from 0 up to 1. So how do we handle the limits? We shall substitute the limit, which is the upper limit. When you substitute 1, you get a negative a quarter into brackets. This is the same as 1 plus 1 power negative 2 plus a constant. Then minus, when we substitute 0, we shall have a negative a quarter into brackets 0 plus 1 to the power negative 2 plus a constant. It is for this reason that whenever we have limits, even if you don't write the constant in your presentation, because the constant will be lost after subtraction, then we shall have finally, if you factorize out, you'll have a negative a quarter into brackets. This is 2 power negative 2, which is going to be 1 out of 4, because it is 2 power 2. Then this is 1 power negative 2. Any number power 1 power any number, you get 1. This is the same as 1 over 1 squared. So it's going to be minus 1. So we shall realize negative a quarter into negative 3 out of 4. And the answer is going to be thrice out of 16 as our answer. So with that, you are dealing with what we call definite what? Integrals. Since this is mathematics, there is no way I can leave you just like that without having a number to try out. So allow me to leave you with an illustration of question 1. Integrate sec to the 5th of x tan of x with respect to x. Number 2, integrate x to the cube of x to the 4th minus 1 to the power 10 with respect to x. Then thirdly, also integrate sine to the 4th of x cos of x dx. I would like to look at some of your comments and some of your solutions in the comment section. You can write your solution right there, or you can take a screenshot if you don't know how to type and write these integral symbols. You can take a screenshot of your answer and take a look at it in our comment section. Otherwise, I would like to thank you so much for being part of this session. It's an academic session, and we are glad that you are watching, you are with us. Today, I'm now in my professional, which is handling mathematics, pure mathematics. And like I've said, you can always log in on the internet and look for more numbers. You can look out for the different books. For example, there is Pure Mathematics 1 by J.B. Backhouse. There is Pure Mathematics 1 by C.J. Tranter. There is Understanding Pure Mathematics by Bostock and Sadler. There is Pure Mathematics by Perkins and Perkins. And then there are also so many other books on the internet and everywhere in the different libraries in the world where you can find integrals handled. So with that, allow me to stop here for today and then meet you again in type 2 of integration. For now, let's have integration type 1. My name is still Hamza Ruwama. See you next time.